Good morning, and I'm afraid I'm not speaking any Spanish, but I'm Italian, so hopefully my English is reasonably easy to understand. My title, as you can see, is referring somehow to a famous test, the Turing test, that I'm sure you have heard about. Is anybody there? Am I talking to a human being or to a machine? We're going to talk about that, and this is actually also the title of a white paper that we just published. I will give you at the end of my presentation the link to download the white paper. I'm not doing it now, otherwise you will all be playing with the smartphone and downloading the paper. So we're going to talk about artificial intelligence a little bit, and many people get a bit uncomfortable and scared when, we think about artificial intelligence, machines doing things instead of us. I'm actually quite positive about artificial intelligence. More than 100 years ago, a scientist wrote this fantastic sentence that civilization advances by extending the number of important operations which we can perform without thinking about them. And if you imagine there were no computers, there was nothing 100 years ago, and he already had this incredible vision that the advancement in civilizations are connected to things that others, machines, can do instead of us. So I'm actually quite positive. I think artificial intelligence is going to advance civilization incredibly. And if you want to have a good feeling of how advanced is artificial intelligence today, there is an area which is perfect to understand that. It's chess computing. I don't know if you are chess players or passionate about chess. I am. I'm a bad player, but I'm passionate about it. And I'm pretty sure you know that since 1997, Deep Blue defeated Garry Kasparov, right? And since then, chess computing continued to evolve. Nowadays, it's simply super strong. No human being can beat a computer in chess. So now the interesting competitions are between software. So which is the strongest software in chess playing? Now, these softwares actually are not particularly intelligent. Stockfish, which is one of the strongest, is just super fast. So it has big memory and it is super fast. So the way they work is they have in their memory all tactics about opening a game, all tactics about ending a game when only few pieces are remaining. And for the middle game, they just try all possible moves and all ramifications of these moves, analyzing the position, and they do that extremely fast. I think Stockfish can analyze 80 million positions per second. So, of course, if you are so fast, you just end up trying all moves and finding a brilliant move. So how can you win against a software that is just trying everything and finding the best move? Well, in December last year, and if you are passionate about chess, I'm sure you know about this, but if you're not, maybe you're not aware, something very, very significant happened. A new software tried a match against Stockfish, and this new software called AlphaZero is an artificial intelligence engine, self-learning, no tactics about opening, no tactics about closing games, nothing. Just a self-learning machine that got as an input the rules of chess. So obviously they had to tell how to play chess to this machine, and then had 4 hours to self-learn chess. So AlphaZero learned the rules of the game, started playing against itself. At the beginning, probably it was a very bad player. And in 4 hours, learning from its own mistakes, it got better and better. On 6 December last year, AlphaZero, after 4 hours of learning chess, did a match against Stockfish, 100 games, and AlphaZero won the match. Actually, I think it won 28 games. All the rest were draw, never lost a game. It even won playing black, which is the less advantageous of the 2 possible games. So this was quite an important moment for all the community interested in artificial intelligence, because a self-learning machine can really do amazing things. And obviously, if you apply that to understanding voice or to movement, you end up with these things that I'm sure you have seen on the internet. I mean, it looks like digital images, I mean, like science fiction movies, etc. It is a real robot jumping left and right. I'm sure, you know, it's nice to see the clip of the successful jump. Then probably there are 100 other attempts when it was falling over left and right. But, I mean, this is absolutely amazing in terms of results that artificial intelligence is now getting at. And if you are interested in reading about it, I'm not connected to the author or to the editor at all, and I actually don't know if it has been translated. But Pedro Domingos is actually Portuguese and is now living in the States and is a professor at Washington University. But this book is absolutely fantastic in explaining artificial intelligence, self-learning machines, how today Amazon, Netflix, etc. are already using artificial intelligence. So it's just a good recommendation if you want to learn more about it. So why am I talking to you about artificial intelligence? Because I think it will have a significant impact in commerce and in the payment technology. We are already using, as Mastercard, artificial intelligence. We are using it first to fight fraud. It's one of the things that artificial intelligence does very well, analyzing lots of data and trying to identify patterns that self-learning are connected to fraud in order to fight fraud. We are also using artificial intelligence to do biometric authentication. One recent acquisition, a company called New Data, has been acquired by Mastercard, and they do biometric authentication, but not the classic one like face recognition, that's also available, but also the way you hold your smartphone or you type in your smartphone can be recognized, so that if somebody steals your phone and you have no blocking pin or anything, and holds it differently from what you do normally, that can be identified. So these are all advancements in artificial intelligence applied to payments, to security of payments, and also, of course, to conversational commerce, which is where I wanted to get at. Now, humans buying things and interacting with machines is not particularly new. Since 2015, Uber was introducing, for example, the possibility of ordering a car while chatting with a chatbot. Chatbots have been used by many industries, so there are assistants where you chat with a virtual assistant, believing that is human, but in reality is software. Last year, we did something similar in the US with Facebook Messenger, and these merchants, Subway, Fresh Direct, and Cheesecake Factory, where you could order a sandwich, chatting with a virtual, waiter, I would say, that would ask you which sandwich would you like, how would you like the bread, toasted or not toasted. It's not very different from surfing a website and clicking on the options that you want. But the interface is a lot nicer, because you really have a feeling that somebody is talking to you, asking you how you prefer things. And Facebook Messenger is the chat used in the States more than WhatsApp. In Europe, probably we would do it with WhatsApp, still the Facebook family anyway. Our role, obviously, as Mastercard was to look after the final phase, the payment, because what we had to prove and test is that our digital payment technology could be integrated inside a chat. So it has to be super simplified. It cannot be too complex. You're not browsing the internet. You're just chatting. And that's what we did. So our objective, our mission is to make sure that it is possible also in a very simplified and conversational interaction to do a payment. But where are now moving to? You have seen a human purchasing with a machine. Would it be possible for a machine to purchase with a human? I know what you are thinking. Why a machine would buy something? Well, obviously, it would do that because we would have asked, as humans, delegating the machine, could you please buy this for me? It may sound super strange, but actually it isn't. The assistants are just helping us do things, so they may also, with the advancements of artificial intelligence, talk to human beings and conduct transactions. Let's have a look at an example that maybe you have seen already, the keynote presentation of Google of this year, demonstrating how Google Assistant was able to talk to a human merchant, a haircut salon, booking that haircut, doing all the conversation as if it was a human buyer.
Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
I mean, this is quite amazing, and it didn't finish with an actual purchase. It was just a booking, but you can easily imagine with card on file, leaving our payment card to the assistant and delegating the assistant to buy a train ticket or things like that. The assistant could easily do it, and I mean, it was really interacting with a human seller as if there was a secretary or an assistant doing that booking. Now, let's go even further. Machines talking to each other and doing transactions. Actually, It may sound like the most science fiction thing. It's the easiest one. Machines have been talking to each other since years and years. It's much easier, actually, because there is no natural language complexity in between. You just need to agree on the protocol that the two machines will exchange. So machine to machine or Internet of Things, this type of commerce is actually technically a lot easier. Now, the example that typically we hear about this is the fridge. The fridge is going to order the milk on its own when it will notice that you don't have milk left in your fridge. And indeed, Mastercard has been working with Samsung to do precisely that, but I'm not totally sure the use case has been particularly successful. I have in mind a much more interesting example of machine-to-machine commerce, which is a device much bigger, actually. It's our cars. Why on earth, when I go to the petrol station, then I need to do things in order to pay? I mean, wouldn't it be much easier if the car just talks to the petrol station and they agree on doing the payment? It's not too complex, you know. You could use Bluetooth or Wi-Fi for the connection, and you just need to agree on the protocol to do the payment. I think the advantages would be enormous. You don't have to leave your car and go away to do the payment, because, you know, things happen when you leave your car in order to do a payment somewhere else. There is no audio. It's totally silent, but pretty clear. Somebody has left the car to go and pay. Uh-oh. Not looking good. Or maybe when you are back after paying, you're thinking about something else. You're totally distracted. Uh-oh. Not looking good either. Yeah, really bad things happen when you are distracted. So it was a joke, but essentially the idea is we can improve a lot the experience of people if we delegate a little bit more devices and software to do things for us. As I was saying at the beginning, we need obviously to trust the whole system. The system has to be secure, and that's where we play a role. As Mastercard, we are a payment scheme. We just work trying to improve as much as possible our digital payment experiences. Now, without being too futuristic, at the moment, this is on e-commerce, the typical use cases that you see. Individuals use devices to make payments, the new, obviously, smartphone payments, Apple Pay, Samsung Pay, Google Pay, smartwatches. We will see more and more of this, and maybe cars very soon, I hope. Then there is the typical card-on-file experience, where the merchant is storing the card details like Amazon does in order to have a much easier experience. There are wallets. PayPal is an example where, again, the card is stored, but they are not the merchant. They're just helping other merchants. And then there is the most complicated use case, which is guest checkout, where you enter manually your card credentials in order to pay. Now, our view is that we should have a way to simplify all these use cases, and we have developed one platform, not two, not four. We have only one. It's called MDES. I'm not getting into the details. It means Mastercard Digital Enablement Service. But it's basically the token engine that is today used by all the banks in Spain that enable Apple Pay, Samsung Pay, or Google Pay, etc. We wanted to apply that technology, that tokenization, also in the internet world, because there are lots of benefits. Otherwise, the proliferation of card details on the internet would just continue uncontrolled, and it would be really complex to manage. But there are also other advantages. For example, with the token, there is associated also the card image, the real image of the plastic card that you have in your wallet. Like, for example, Apple Pay or Samsung Pay or Google Pay do. They show you on the smartphone the real image of the card. Now, would it be nicer if also the e-commerce merchant, Amazon, PayPal, etc., could display the real image when you shop? At the moment, you have to remember the last 4 digits or things like that. So also in terms of user experience, there are improvements that tokenization can provide. And the most important one is approval rate, which is dramatically better if we use EMV technology, so tokenization. The guest checkout, the last use case, is the most complex. If we want to replace that experience, which is indeed not nice, entering manually card data, we need to agree on a common standard. So what it has been decided is that Mastercard, Visa, Amex, all the card schemes are now working on a single standard called SRC, Secure Remote Commerce. I think the specs, the first draft spec has just been published. So very soon we should have a single way, a single button to complete guest checkout payments without entering manually the card details. Otherwise, conversational commerce and all these advancements would not be possible. So this is what we are doing. This is our strategy. This is a much more detailed slide. I don't think you can read, it's too small, but you may get a copy in that white paper. It just lists all the components of this platform, and you will see there are the 4 use cases and multiple interfaces, including voice, text, etc. So various ways of completing the transaction. Our mission, and I think also what technology today allows, is to have a combination of security and ease of use. In the past, it was not that easy. Very often, in order to have something very secure, you had to have a very complex process, or if you wanted to have something very, very easy, you had to compromise a little bit with security. Nowadays, technology really allows to have a perfect combination of both. With biometric authentication, you can have strong security and a very easy to use interface. By removing PAN numbers from the digital world, which is our mission, and replacing them with tokens, I think we can have really a perfect match between security and ease of use and nice user interface. So with that, I thank you, and as I promised, if you want to take a picture directly on the QR code, you will get to that website to download the white paper. I hope you will find it interesting, and if you have any question, I'm here. Thank you very much.